Hey, what's up guys? Today we're going to go over reflections. So first, going to remind you about horizontal and vertical lines, some pretty common ones, and some diagonal lines. So firstly, we have the x-axis and the y-axis. So there's an acronym, VUX, HOI. The VUX stands for vertical, undefined slope, x equals. So when you have a vertical line, the slope is undefined and it's expressed as an x equals. Conversely, for horizontal lines, you have HOI. So horizontal lines have a slope of 0 and you express them as y equals. So we have our horizontal line here at 0. So this is y equals 0. For the y-axis, we have a vertical line. And we express this as x equals 0. Moving on, I'm just going to choose some random numbers. So let's say you wanted to graph x equals 2. So again, remember your acronym, VUX, HOI. So VUX, so x equals, so that's a vertical line at 2. So this would be right here, x equals 2. Okay, for y equals, I'm going to just choose 3. So again, VUX, HOI. So y equals is a horizontal line at 3. And that's it. For diagonal lines, we have y equals x and y equals negative x. Don't forget from algebra 1 that that is just a linear line in point slope form. You could rewrite it like this if you wanted to, but it has a slope of 1, a y-intercept of 0. So it's basically just going to cut through these corners here. Y equals negative x. It's the same thing, except now the slope is negative, so it's going to decrease going from left to right. So this is y equals negative x, and this one is y equals x. The y equals x line you'll become very familiar with in Algebra 2 when you learn about inverses. Okay, next, this is on the next page. So description and rules for reflection. So the first sentence is the figure is flipped over a line of reflection. So the line of reflection pretty much acts like your mirror. So each point is each points on the image are the same distance from the line of reflection. Now this isn't a very important fact that we'll keep circling back to. Notation. So we kind of have a little cheat sheet here that shows you how different reflections work, pretty special ones. So, and common. So reflection in the x-axis, we have the ordered pair x comma y, and then after reflection over the x-axis, it becomes x comma negative y. So all that happens is your y coordinate changes sign. Similarly, but opposite, reflection over the y-axis, we have x comma y changes to negative x comma y. So you just change the sign of your x coordinate. Reflection in the line or over the line y equals x, we start off with the ordered pair x comma y, and that will change to y comma x. So you actually flip-flop your x and y coordinate. And again, once you learn about inverses, that will make a lot of sense. Reflection over the line y equals negative x, we have x comma y turning into negative y comma negative x. So these are basically your cheat codes right here. Under properties, you have pre-image and image are, corresponding angles are, corresponding sides are, and there's all these blanks. For these blanks, we do the congruency sign, which is the two equal or the equal sign with the tilde above it or squiggly line. Congruent just meaning that once you reflect the image, no features of it really are changed other than its position. It still has the same angle, same side, etc. So let's look at example 1. We have reflect triangle ABC over the x-axis. Well, hey, reflection over the x-axis was one of our cheat codes up here. So we have that rule handy. X comma y changes to x comma negative y. But first, before we do that on our graph, let's go ahead and draw that line of reflection. That's going to be the x-axis right here. So y equals 0. So A is 2 comma 3. So A prime, once we reflect A over the x-axis, will turn into 2 comma negative 3. So let's go ahead and plot that. 2, 3. So right here is A prime. So B, 3, 1 changes to 3 comma negative 1. So 1, 2, 3, 1. This is going to be B prime. And 1 comma 2 for C changes to 1 comma negative 2. And we have our triangle there. Boom. So if I folded this graph over the line of reflection, the shapes would fall on top of each other, which is what we want. Example 2, I'll leave to you. It's similar to example 1, except reflection over the y-axis. I will now go to example 3. It says reflect square RSTU with these vertices over the line x equals negative 1. So again, first, let's sketch our line of reflection, which since it's x equals negative 1, is a vertical line. So the rule, right, when we look up, we don't really have a rule or cheat code like for these other ones for when you're reflecting across just a normal vertical line, such as x equals negative 1. So what we have to do is look at what's in between these red asterisks I put here. That's going to be the important fact that helps us here. Each points in the image are the same distance from the line of reflection. So let's look. Relative to the line of reflection, let's first look at vertice R. R is at 0, comma 3. Okay? If I look at the line of reflection, R is 1 unit to the right of the line of reflection. So R prime is going to be 1 unit to the left of our line of reflections. That's R prime. And that is negative 2, comma 3. Similarly, S is 1, 2, 3, 4 units to the right of our line of reflection. So that means that S prime is going to be 4 units to the left of our line of reflection. So 1, 2, 3, 4. This is S prime. And do that again. That's negative 5, comma 3. Do the same thing for U. U is 1 to the right of the line of reflection. So U prime is 1 to the left. Okay. T is 4 units to the right of the line of reflection. So T prime is 4 units to the left. They all line up nicely as they should. This T coordinate is negative 5, comma negative 1. And this U coordinate is negative 2, comma negative 1. And that's it. And again, if you folded that across the line of reflection, the shapes would fall directly on top of each other, and the vertices would also match up. I'll leave example 4 to you. It's just using the reflection over y equals x rule. Example number 5 says working backwards. It says given image point R prime as negative 5, comma 3. Let's just stop right there and go ahead and plot that point. Negative 5, comma 3. That's R prime. That is our image. And it had a reflection across the line y equals 2. So y equals 2, that is a horizontal line. Let me do that a different color because it's y equals hoi, so horizontal. So that is y equals 2. It says, what is the pre-image of the point R? So here's the thing with reflections. Working backwards is not really a thing considering everything's kind of symmetrical. It doesn't really matter that they told us that it was the image and they're asking for the pre-image. Even if you interchanged that, the answer would still be the same because of the fact that we know each points are the same distance away from the line of reflection. So, okay, R prime is 1 unit above the line of reflection. So R is going to be 1 unit down from the line of reflection. So that's R. And that point is -5, comma 1. And that is it. Thank you, guys.